Hello everyone, welcome to another video. I am going to be doing a series on how to get a job in network engineering. I don't know where this is going to go. This could evolve into me just doing maybe over 100, 120 CCNA labs covering all topics. Or this can turn into me just creating, as I'm doing interviews out there in the world, I'm going to just put together some labs that I think are beneficial to people that want to become network engineers or senior network engineers. I really want to make labs in Cisco Packet Tracer that exemplifies what you would be doing in an interview. So I'm not really going to rip off these interviews completely, but I'm going to just really do some prep, like a network topology, load balancing on a network, and those are some ideas and plans I have for the future. Maybe stuff using like spanning tree protocol and OSPF and other topics that are on the CCNA. But I think for this lab, this is a pretty standard topic. When you go to a network engineering interview, they may actually throw a physical switch, a physical router, and give you a laptop or PC and say, okay, connect this to the internet. And you're gonna have to actually know how to do that. So I want to take the time. This video might be slightly longer than my normal videos, but I just want to take the time to work through this. I worked through this a couple of times today, and I did make some mistakes and learn throughout the process. And it's going to be a little tedious. I'd rather we make those mistakes together than you make them and flunk an interview that can change your life. So with that, I'm going to open Cisco Packet Tracer, and then we're just going to get started. So just the lab setup is going to be quite simple. Let me get our devices. I'm going to get one PC. So we'll start with the PC. We'll grab our network devices. So we're going to get a switch. So a PC, a switch. Then we're going to do, let me see what router I'm going to use. I've written it down somewhere. I'll use a 2911. Then another thing I want to do is the cabling. Technically, the way we would cable is these are straight throughs all the way through. And then router to router is going to be a crossover cable. So I'll use auto just to show you. Oh, no, I have to use a straight through. Sorry. Because there's a way I'm going to go about doing this. It's a lot of steps. I actually spent like 3 or 4 hours writing each step down. So I got my end devices. I'm just going to actually name everything just for my own sanity. So this will be PC1. This is just building a lab from scratch. I think you should do this. I really do. I think you should get Cisco Packet Tracer and honestly follow along with me as we're doing this. And then we'll go into the routers. We're gonna play around, and if you don't know anything, this is great. Make an account with Cisco Packet Tracer. So we renamed our devices. We're gonna cable the devices. So for this lab, we're gonna use straight through cables, and that's fine. So Packet Tracer also supports like auto cabling, which I'll do that. But one thing you need to understand is the switch and the router of today have something called auto MDIX. That means whether you're using like a crossover or a straight through cable, there's enough intelligence in those switches and routers and those machines to know how to route traffic. So I'm going to go from PC1, fast Ethernet 0 to switch 1. Let me see the one I wrote down for it. So we're going to use 0, 1. And usually when it's green, then I know it's good. We can even open the switch right now and CLI and see, it already tracked that we plug something in that has power and it's already up. So that port is already up. So switch 1 to R1, we're going to do straight. And this is why if I did auto cabling, I wouldn't have the opportunity to change everything. So let me just do that. So more straight through. Then we'll just do 24. Then R1, we'll do G00. Let's take about 30 seconds to go up. Then R1 and we're going to use crossover. This will be G01 to G00. And we'll see all this come up in a little bit. So in this lab, what is our switch going to do? Our switch is basically going to be just a layer 2 switch. Since PC1 and R1 are going to be in the same VLAN by default, the switch will forward Ethernet frames between PC1 and R1 without any extra commands. We would kind of just call this like a dumb switch, in my opinion, where the switch literally just acts as like this access layer and nothing else. It's not like a multi-layer switch or layer 3 switch where it has like routing capabilities. It's not a switch where we're like throwing a bunch of VLANs in there and have to like think about how we're going to route our traffic. It's simply just going to be for just the transferring of data and packets. So we're going to configure PC1. Let me go. So fast Ethernet 0. We're going to hit static. We're in interface. And there's a couple ways you can do this. I like using config, but you can go to desktop and IP configuration, go to static, IPv4 address, and change the default gateway. That's the first thing we'll do. 192.168.1.1, our DNS server, 8.8.8.8. Then our IP address of our machine, 192.168.1.10. And our subnet mask, I'm going to tab and it'll autofill our subnet mask. So you can see how I did that. Or I can just, manually type it in. 5.255.255.0. So why is this important? That's a question I always like to ask myself, even just when I'm teaching. So the default gateway is the most important host setting in this lab. So PC1 uses 192.168.1.1 when it needs to reach anything outside of 192.168.1.0, like the r/24 network. So when it's exiting the network, then that data passes through the default gateway, which would be our router, and we'll set that up. We don't have to do this, but I'll just do it just for practice. So I'm going to go to N just for enable, but I'll write out the full command. And I believe we're in user exec. Now we're going to privilege exec, and then conf t, which is just configure terminal. But I'll write out the full command for you. And what I'm going to do is I'm going to change the name of the router. So you can see how it just says, or switch, sorry. You see how it just says switch? I'm going to do host name, SW1, and then boom, our host name is changed. I'm going to exit. I'm going to end. Actually, I'm not going to end yet. I'm going to write. That just saves the configuration. So if the switch ever lost power, any changes that we made are saved. All right. So setting up R1. The same thing. I'm going to go to CLI. I'm going to hit no. Here, it's a new router we're setting up. So enable conf t, host name R1. And then I'm gonna try not to use so much, like, I guess. No, I'm gonna use just shorthand. I like using shorthand commands. Just have to like type everything out. So we're gonna go to the interface G00. You see it changed from config to config-if. We'll do a description. My typing's gonna be slow, so just bear with me. We have our description, and the description will describe that specific port. If you do like a show IP route or anything in the future. So we'll do IP and 192.168.1.1 or then 255.255.255.0. And then IP NAT, and I'll explain all this later. Inside, so NAT is going to be our network address translation. So IP NAT inside, no shutdown. So that changes our port, our specific port that we are using will go from the administratively down state, because routers, all the ports are in the administratively down state. You have to actually, in a sense, turn them on by doing the no shutdown when you configure the port and the IP address on that port. The difference between the router and the switches are usually always in the up state. So once you plug something in and it's getting power, it goes from down to up. So essentially switches are always in that up state and routers are always in that down state. So we're still in config if. I did the no shutdown. I'm going to do an exit command. which you essentially don't have to, but just for the sake of the lab, I want to. G0/1, back to config if, description. So this is going to be our WAN to ISP, IP add, and I just did a tab here. When you put in a part of the command, if you tab, I don't want to use. So tabbing just like will fill out the command. So I'm going to do 203.0.113.2, 255.255.255.252. And this is for our ISP router. And we're going to make a loop back. I'm going to show you why we're doing this. So IP net outside, no shutdown, exit. And then we're going to, this is actually pretty important, so don't mistype here. We're going to do access list 1 permit 192.168.1.0, our default gateway, 0.0.0.255. Then we're going to do IP net inside source list 1 interface G0/1 overload, enter, IP route 0.0.0.0 0.0.0.0 203.0.113.1. Okay, and we're done with the router, so I'm going to do an end. And then I'm going to write. So you could do write, you could do write memory, and I believe you could do show, what was it, show startup config, show running config, or copy startup config, copy running config to build out your configuration. So you could do write, you could do write memory. That also works. And then there's a longer one, copy. I believe it's copy dash running config, copy dash startup config. So our IP address, you know, we did the IP address 192.168.1.1, and then the 255.255.255.0 for R1. That makes R1 the gateway for the LAN, which is the local area network. When you go to network engineering interviews, they may ask you to describe what's the LAN, what's the WAN, what's the WLAN. You need to know these things, and I'm going to teach you them as I'm going through this lab. The wide area, so the WLAN is your wireless LAN. This could be like your access points, how are you accessing the internet wirelessly. And then our LAN, our local area network. And the local area network, that could be limited to a home, an office, even a hospital, but it might be a little bit more complex in those situations, or some type of office building. You might have a LAN connected to the WLAN, like our access points, or our routers, or I guess our Wi-Fi routers, like if we're home, connected to maybe like this wireless mesh network, or a wired mesh network. So you need to understand the WLAN, be able to explain that, be able to explain briefly the LAN, the local area network, and then the WAN. The way I explain the wide area network is that's the greater internet at large that connects cities to cities, counties to counties, countries to countries, businesses to businesses overseas, or locally. So anything outside of our localized network, whether that's like our building or our small office, once we exit that, we're entering out into the wide area network, the greater internet at large. So just keep that in mind. So we're done with R1. So IP net inside. Let's go to the command here. So I conf t in the .1.1.255.255, that was to make, so I'm going to go over it again. That was to make R1 the gateway for the LAN. IP net inside. So what does this mean? This makes the LAN the local area network interface as the private inside side of this local area network. So the IP address 203.0.113.2. This gives R1 an outside wide area network IP toward the ISP, towards our internet service provider. If you look up your home's internet, you may have an address similar to this. Maybe not a 203, it could be something different, but it'll be the IP address assigned to maybe your home, that all the computers on your network that may be on like a 10 dot or 192.168, they're going to use that IP address given to you by your ISP, that single IP address given to you by your ISP, to reach out to the wide area network, to the greater internet. So access list 1 permit 192.168.1.0, then the 0.0.0.255. What does that do? That identifies which private LAN, which private local area network addresses are allowed to be translated. And then IPNet inside source list 1 interface G01 overload, that turns on PAT, it turns on network address translation overload. Basically, we're able to translate many inside hosts to R1's WAN interface IP, or internet protocol IP. And then the IP route 0.0.0.0, 0.0.0.0, 203.0.113.1. This sends all unknown destinations toward the ISP router. So a CCNA concept that you would know, or you'll get to know as you're studying, is the default route is often called the gateway of last resort. This is something I've heard quite a bit going through Germany's IT labs, because he talks about the default route being the gateway of last resort. So that's something like that stuck in my head. R1 uses it when the destination is not in the routing table. So if the destination is not in the routing table, it's going to use that gateway of last resort to kind of just push traffic. So now we're going to graduate from our R1 and we're going to go to our ISP router. So this connection's okay now. Let me just see something real quick. Just really fast. I want to see if I can just ping 192.168.1.1. Okay, so I'm actually able to ping my router here. Let me see if I can do it in simulation mode. So let's pull it up. So I'm pinging. Just to give you a visual of what's going on. So R1 sending a message back. And boom, we got a reply from 192.168.1.1, which is our router. TTL 255 bytes 32. And I just want you to see it. And I believe this is called like ICMP echo request, our initial ping, then ICMP echo reply, which is the response from the router. And that's it. So you're just honestly getting a view of that. And I just want you to see that just for your own. It just kind of helps the mind understand a little bit. So I'm going to go back to real-time mode. So now we know we have it set up to the point where we can ping our R1 or our router. That's how normal ping looks. So we can see there. But, we can't ping our DNS server. So unreachable. So now we go for our full ISP configuration. So R1's configured, PC1 can reach R1. And these are things that you're going to want to test and show the interviewers. Now, this is not the only lab. I have about 10 to 15 in my head that I kind of just want to get out. So this is the first one, but I have like literally one right on the top of my mind that I'm going to build out and test. Might do spanning tree protocol or OSPF, but we'll get right to it. I don't want to bore you. So the initial configuration dialog, almost always no. I have physical equipment behind me. I've done yes and gone through it. I might end up breaking something, so I'd rather just hit no and do it myself. So we're going to go enable. We're going to go conf t for configure terminal. We're going to change the host name. So we see it's called router. That's the name right now. We want it to be called ISP. So now we're here. So we're going to do interface G00 on the G00 interface. It's also called the Gigabit Ethernet 0/0 interface. So I'm going to do the description. WAN to R1, IP address 203.0.113.1255. Our subnet mask 255.255.252. So it's 255.255.255.252. No shutdown. Exit. Sometimes I get a little wild and I just want to, save, I guess, real quick. I want to hit save or something happens. Interface, loopback, 0. All right. So description. I'm going to do simulated internet 8.8.8.8, which is Google's DNS server. IP address 8.8.8.8, 255.255.255.255. And then exit. And all right. You want to hit save. All right, so a little explanation. Why do we do the 8.8.8.8? So, and then even like set up a loopback. So why are we using a loopback for 8.8.8.8? So a loopback interface is a virtual router interface. It stays up as long as the router is up. It's to make this test a perfect simulated internet destination for a beginner lab. And then do we need a route back to PC1? Like, how is data going to get from our ISP back to PC1? If PC1 were like to ping or send some type of request or data through. So for this NAT version, this network address translation version, no extra route is needed back on the ISP. And this is going to be because R1, our router 1, translates PC1 source IP, that 192.168.1.10 to 203.0.113.2. So the ISP router only sees traffic coming from R1s. And this is something I want you to understand. You may make a request right now on your home computer. It may be a 192.168 IP address, but that's local on your local area network. You're going to be sending requests through the switch. How our switch is sending data. This is an access switch. It's a dumb switch. So it's just passing data along to the router. It's not routing any traffic or anything like that. It's just passing the data along, passing the packets along. But switches operate on that MAC address layer, the layer 2 of the OSI model. But R1, that operates at layer 3 of the OSI model, responsible for our routing. So as data is being routed outside to the ISP, maybe on the telephone wire or your Starlink or your 5G, is your 192.168 address or 10.0.0 going to show? Nope. It's going to be your primary IP address assigned by the ISP. Maybe coming through your modem. Your router will have your ISP IP address. So in this case, ours is going to be the 203.0.113.2. So the ISP is only going to see traffic coming from R1's WAN IP, the wide area network IP. The reply goes back to 203.0.113.2 and reverses the NAT translation, the network address translation, or NAT translation, back to PC1. So we're basically sending data and then receiving data. Essentially how the internet works. How I'm even doing this right now. So the next step is going to be to test and verify. So we already tested one. So we know that we can ping our router and get a request back. I don't know if we can do this. No, trace route just shows how many hops it took via IP addresses to get to your location. It was just one hop just straight to our router. So our ping was successful. So we're going to ping 203.0.113.1. And I'll explain something else. What actually took place here. show you this. I kind of wish I can go back. Anyways, what I wanted to show you was what took place. Why did that first ping fail? There's a lot of questions people have. So PC1 did a request to R1. This is called address resolution protocol. It's called the ARP protocol, address resolution protocol. So usually when maybe the computer or I believe the router doesn't have a specific, basically PC1 can leave its local network. R1 is routing toward the ISP and the R1 to ISP link now we know is working. The router might not have had, I guess, the IP address in its routing table, and now it does. With that failure, information is being shared. That's why we see the next replies worked fine. I was hoping that we can see ARP kind of just pop up, but we didn't see ARP pop up. But I don't think I did my simulation correct. So our ICMP echo requests, our pings are going through now. So the ISP is receiving data, and what's it going to do? I'm going to send it back, passed all the way through the ISP, R1 routed it to the switch, and the switch is going to transfer data based on the MAC address of the specific port that is sending out that data, and now we just received data from our internet service provider. I'm probably not explaining it perfectly, but I'm pretty sure you get the sending and receiving of data, which is important to be able to explain, and you may get an interview question or may have a literal switch and router drop right in front of you. So one of the labs I have in mind is I'm actually going to do the lab in front of the equipment on a video camera or an iPhone, and I'm actually going to do it live and show you how to get on the internet. I'll go to real-time mode. So we know we can reach our router, the ISP's router. Now, can we reach the simulated internet? So we're still on PC1. So I'm going to ping 8.8.8.8. And we might see, so we have an ICMP echo request through. I want to see if we see any ARP. Okay, we didn't see any ARP. Maybe I'll do a lab just to show you guys ARP, because I think it's something that you guys should be knowing. You guys should know. But nonetheless, our packets are sent and, you know, are sent and received. We got the ICMP echo request out, and we got the ICMP echo reply. So I guess test 3 was to, can PC1 reach our internet? And we did. So we successfully set up our PC, which, let me just go to config, then interface. So you can see here, we have our default gateway, our DNS server, which is our simulated internet, then fast ethernet, our IPv4 address, which is static, the 192.168.1.10, our subnet mask, 255.255.255.0. So we set that up. On R1, we'll just verify some of the commands. So I'll just enable, I believe this is privileged exec mode or user exec mode. I forget. So do show IP interface brief. I'm obviously like using shorthand. So we can see G00 and G01. So G00 is coming from our switch. Then the 203.0.113.2, the G01 on our router is going to our simulated ISP connection. And then another thing we can look at is the show IP route. I'll just make this bigger. These are things you learn. I think one thing you know is the connected route. There's a C here, the local route, which is the -32, and our connected and local. I forget the S star, but it looks like it's pointing to our ISP. We can do another one, show IP NAT translations. Did I do something I'm not supposed to? Show IP NAT statistics. Okay. This is great. So the show IP interface brief that I did earlier, that's G00 and G01 are up. That's a good sign. Problem would be if G00 and G01 were administratively down. If they were down, like if these were showing like administratively down, like the 02 in our VLAN, that would mean we didn't do the no shutdown command. Like we missed the no shutdown. So show IP route. Where did I do that one? Show IP route, the default route, that S star 0.0.0.0/0 exists. That's a good sign. A bad sign will be there's no gateway of last resort, which Germany IT Labs stresses. Show IP NAT translations. The translation appears after a ping. A problem will be no NAT entries. The show access list. Let's go here. $10 permit. So ACL means access control lists or access lists. So it needs to show matches. If it doesn't, if it has like 0 matches, that's a problem. We can see we have 32 matches. We're doing good. That's pretty much it. A troubleshooting guide. If PC1 cannot ping, I'll put these. Actually, I'll make a GitHub for the troubleshooting guide. That's when you can just go through yourself in preparation for your network engineering interviews or your CCNA studies. I'll probably throw this lab in both playlists. Some of the skills you're demonstrating, I would say, is IPv4 addressing and subnet mask, the default gateway configuration, which is super important, Cisco router interface configuration, which is very important, the static default route configuration, the NAT overload with PAT, basic layer 2 switching, which we essentially did that, end-to-end ping testing, structured troubleshooting, which we have a troubleshooting guide in the GitHub I'll go through, and then just clean documentation and portfolio presentation, because you can actually write out a lot of this stuff, bring it along with your interviews. Not that you're gonna like use it as a cheat sheet, but you can say like, hey, this is what I worked on before I got to this interview, or you can just have stacks. In one of my next videos, I'll show you what I take to interviews. I usually bring a briefcase and I'll have 50 to 70 pages of my portfolio. And my portfolio may include written projects like this one and written guides. So we go over it again. We successfully connected this PC to the internet and we're able to ping Google's DNS server. So thank you for watching and have a great day.